right, good morning, good afternoon, good day, everyone. Today, you're starting off your do now with a little bit of practice. Your practice is going through and utilizing function notation. Remember, function notation. So if I have the function notation tells me that I am substituting this value in for x. So here I just have 3 plus 2 times -4. And I'm going to evaluate that. And that's going to give me -5. Okay, you're going to be doing this on your own paper. I encourage you to do the whole thing, but do as many as you want, just to practice and be comfortable with what you're doing. All right, to start our notes, we have 1, 2, graphing and analyzing functions. And so that's what we've been working on all week. And we're going to kind of come to the conclusion of it today. Yay! So we all recall how to graph a linear equation. So when graphing a linear equation, we usually are in slope. That's not how you spell slope, though. Dun, dun, dun. Yes. We are typically in slope-intercept form. Slope-intercept. Right? Slope-intercept, and that's because M represents my slope, which is my rise over run, right? And B represents my y-intercept. And my y-intercept is 0, B, right? So when I look at this, we're going to use this to graph by hand. So first I have that my slope is 2. So that means 2 over 1. So I'm going to rise 2 and I'm going to run 1, right? Starting from here, my y-intercept. My y-intercept is starting at 0, 3. So starting from 0, 3, I'm going to rise 2, run 1. So I'm going to go to 0, 3. And from 0, 3, rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I'm going to repeat this pattern, but going down and left 1. Down and left 1. Down and left 1. And I'm going to connect these points. Now I'm going to do my very best to connect them as straight as possible. But I'm going to tell you right now, you have to use your imagination and pretend that this line is going through every single point. And it's the straightest line you've ever seen. Okay? So that is graphing a linear equation. So step 1, let's write what we did. So let me change colors for you. So step 1, we plot the y-intercept. Step 2, we use slope to plot additional points. And then step 3 is we connect the dots. Connect the points. And bam, you're done. Okay? So graphing a function using a table. First, you're going to determine the parent function. Second, create a table of reasonable values. Third, use function notation to evaluate those 3 to 4 points. And then 4, plot the points and connect them. So here we have 2x squared plus 3. Well, 2x squared plus 3. Step 1 says identify its parent function. Looking right here, my parent function would be quadratic. Quadratic x squared, right? And so with quadratic, we know a couple of things. We know what shape it looks like. Okay? And we know that quadratic has reflectional symmetry. Reflectional symmetry. So if I'm going to choose 2x squared plus 3, I'm going to choose equal amount of points. So let's say I'm going to go easy, and let's do, what can we do? Let's do 0, -1, 1, and 2. Let's do that. So I'm going to use function notation and plug them in. So I have 2 times -1 squared plus 3. Evaluate that. That gives me 2 times 1 plus 3, which equals 5. I'm going to use 0. So I have 2 times 0 squared plus 3 equals 0 plus 3, which equals 3. I'm going to do 1. 1 is 2 times 1 squared plus 3 equals 2 plus 3, which equals 5. And I have 2 times 2 squared plus 3 equals 2 times 4 plus 3, which is 8 plus 3 is 11. I'm going to plot these points. I have -1, 5. I have 0, 3. I have 1, 5. And I have 2, 11, which goes off the page. Alright, because this is reflectional, I know that if 2, 11 is here, then -2, 11 also must exist because of that reflectional property. Now I'm going to do my best and connect the dots. It didn't even look like I tried. It didn't even look like I tried, but I promise I did. Let's try that again. Look at that. Yep. Got a little better. We're going to pretend that that went through all the points. Okay. Now that wasn't too terrible. Okay. How do you find the y-intercept of a function? So to find the y-intercept, you're going to plug in 0 for x and then solve for y. So we're going to plug in 0 for x and then solve for y. So here's x. I'm going to substitute 0 in. That's going to give me y equals 0 plus 3. So y equals 3. So therefore my y-intercept, and then the y-intercept is an ordered pair, my y-intercept is at 0, 3. Yay! Okay. How do you find the x-intercept? Well, for x-intercept, you're going to plug in 0 for y, and then solve for x. So I'm plugging in 0 for y. I'm going to use inverse operations. I'm going to subtract 3. And that's going to give me -3 equals 2x. Divide by 2. And I get x equals -3/2. So my x-intercept is at -3/2, 0. Okay. Alright, so we're going to talk about how to find the maximum and minimum of a linear function. So when you're looking for the maximum and minimum of a linear function, you're going to create a table, use the given interval as your x values. So we are given the interval 5 to 10. Plug in x values and solve for y. The smallest y value is your min and the largest is your max. So I have 5 and I have 10. And I'm going to plug them in. So I have f of 5 equals 6 times 5 minus 7. So that's 30 minus 7, which is 23. And then we have f of 10, which equals 6 times 60. I said 60. 6 times 10 minus 7, which is 60. minus 7, which equals 53. So after I've done this, I now know what my min and max value on this interval is. So my minimum is 23, Jordan, and my max is 53. Easy enough. Okay, now let's put everything we did all together. So we have the function 3 minus 5x. And we want to identify the domain, range, x-intercept, and make a little graph of it. So to find the domain, you got to think about what is its parent function. What is the parent function? Well, the parent function is linear. And what is the domain of linear functions? Well, that's from negative infinity to positive infinity. What is the range of the parent function? It is from negative infinity to positive infinity. Okay, so that applies to all linear functions. Now, finding the x-intercept. X-intercept means that you're looking for x, 0. So that means your y is 0. So I have to plug in 0 for y. So we have 0 equals 3 minus 5x. And we're going to solve for x. So the first thing I got to do is subtract 3, inverse operations. I'm going to be left with negative 3 equals negative 5x. Last thing I'm going to do is divide by negative 5. And I'm going to be left with x equals 3/5. So therefore my x-intercept is at 3/5, 0. Okay, y-intercept. Y-intercept means you have 0, y. I have 0 for x, so I'm going to plug in 0 for x. So we have y equals 3 minus 5 times 0, which leads to y equals 3, because anything times 0 goes away. And so therefore my y-intercept is at 0, 3. Okay? And then it wants us to evaluate the minimum and maximum on the interval from negative 2 to 5. So I'm going to evaluate the interval with the value here. So I'm going to first do the first number. So we have f of negative 2, which equals 3 minus 5 times negative 2, which equals 3 plus 10, which equals 13. So at f of negative 2, I have 13. Now I'm going to do f of 5. And f of 5, I get 3 minus 5 times 5 equals 3 minus 25, which equals negative 22. So, based on the results that I have, my maximum value is, on that interval, 13. And my minimum value on that interval is negative 21. Okay, the last thing it wants us to do is to draw a graph. So my graph isn't going to be perfect. It's going to be a little sketchy sketch. So I'm going to create a little coordinate plane. And this is my y-axis. This is my x-axis. And I'm going to actually use the points I've created here to help me graph this. So after going through this, I have found my x-intercept, my y-intercept, and I have found negative 2, 13 as a point, and 5, negative 22 as a point. Can't really put them on here, but if I could, if I count by a certain number, I can. But I'm going to use my intercept. So I know my intercept is 1, 2, 3. There's my y. And I know that my x-intercept, it's not quite as big on 1. So I'm going to make my 1, I'm going to count by 1s here. So I'm going to say this is 1, this is 2. And I'm just going to, and I'm going to now, I can graph 3/5. And I'm going to do my best to connect the 2 points. We all know I struggle. I am seriously concentrating. Boom. There's my sketch. I didn't know where my 3. There's my sketch of my graph. Alright, so on the next page, I would like for you to pause. So you're going to pause and do this example by yourself, and then come back and check, and we'll see how you did. Alright, so we are back. Again, you're going to always start off with identifying your parent function. So the parent function here is linear, so I know that my graph is going to be, domain is going to be from negative infinity to positive infinity. My range is going to be from negative infinity to positive infinity. To find my x-intercept of any graph, you're asking yourself for x, comma 0. So you know that y is going to equal 0. So we have 0 equals negative 5x plus 6. I'm going to subtract 6. And that's going to lead me to negative 6 equals negative 5x. I'm going to divide negative 5. And that's going to lead me to x equals 6 divided by 5. So therefore my x-intercept is at 6, 0. If you really want to write this as 1 2/10, go for it. My y-intercept is at 0, comma y. So I know that x has to be 0 in this case. So we have y equals negative 5 times 0 plus 6. Or you can just remember that you're in slope-intercept form and know that it's 6. That cancels out. And I'm left with y equals 6. So therefore my y-intercept is at 0, comma 6. On the interval determining which is minimum and which is maximum, I have negative 1 and positive 6. So I'm going to evaluate f of negative 1. Plug that in. I get negative 5 times negative 1 plus 6, which equals a negative times a negative is a positive. So 5 plus 6 equals 11. Now I'm going to do f of 6. So f of 6 equals negative 5 times 6 plus 6 equals negative 30 plus 6, and that equals negative 24. So now I've found the values. I'm going to determine which is max and which is min. 11 is my max, and negative 24 should be my min. Okay, last we're going to practice doing a sketch of the graph. This time I'm going to go over with you graphing with use of your y-intercept and your slope. Remember this guy, your b and your n. So that's it. So here's your homework. Do your homework. Let me know if you need help or if you have trouble accessing, but it should be there and ready.